So here we're going to start talking about section 1.7, which is basically linear and absolute value inequalities. And the first thing that we're going to talk about with respect to all this stuff is interval notation. So interval notation should theoretically be something that you've seen before. Interval notation basically works something like this. Consider that you have a number line. Actually, I'm going to make that a smaller number line. Say we've got a number line here. And we've got numbers going from 3 to 5. Now, if we want to indicate that our solution is between 3 and 5, including those endpoints, we would draw something that looks like this. Now, depending on when you learned this, probably if you had this a while ago or if you had this in high school, you might have seen something like this. Closed circles, and then the line filled in. So again, closed circles, and then the line filled in. These are the same thing that they're talking about. It's just different notation. So now the brackets are taking the place of the filled in circles, and this is just the way your book does it. The reason that your book does this is because if you graph it that way, to actually write it in interval notation, you would write it by saying bracket 3, 5 bracket. So you're saying that my solution goes from 3 to 5 and actually includes the points 3 and 5. The other notation that we'll talk about is set builder notation, or just set notation. And that's the one where you go like the curly brace x such that 3 is less than or equal to x is less than or equal to 5, curly brace. Now, the equal sign here that we have, less than or equal to, it's because we're equal to the endpoints there. So that's why. So you really want to make sure that you've got a solid understanding of why we're putting less than or equal to signs there. Another note on these right here, on these signs are always going to face the same direction, and they're always going to face to the right whenever you're writing it in set builder notation. Remember, these are like, if you remember doing this in like grade school, and there's like, the alligator eats the bigger number. The alligator is always going to the right, so if that helps you remember something, go for it. That looks like fish with teeth. Piranha always goes to the right, this way. Just trying to get off the page. So remember that they're always going off to the right. If you put together set builder notation, you have those going the wrong way, you're going to be in trouble. Okay. So next kind of thing that we could have would be something looking like this. So we could go from 3 to 5, but we don't want to include the endpoints. So we would include like 4.9999999, but not actually include the 0.5. So we indicate that by using parentheses. We would indicate that the old way that you might remember doing it by doing open circles. Open circles. Now, oops. The theory behind doing the parentheses instead of the open circles, again, is so that if I wanted to write this particular interval in interval notation, I would do open parentheses, 3, 5, close parentheses. And then in set builder notation, it would be x such that 3 is less than x is less than 5. But it wouldn't be less than or equal to. It would just be less than, because I'm not equal to 5. And that's the whole point, is I can't be equal to 5. Now, variations on a theme. We can go through here and, one of the sides could be equal to, and one of the sides could be less than, but not equal to. So this side could be equal, and this one could be not equal. So like 3 would work, but 5 wouldn't. So we would basically go from 3 to like 4.99999. And you would again write this just by reading the intervals right off of the graph. So it goes from 3 to 5, parentheses. And again, the set builder notation is x such that 3 is less than or equal to x is just less than 5, but not equal to 5. Alright. Now there's a couple more things that we can have. We can go say from 3, we can go from 3 and say, well, we're going to go all the way this way forever and ever. We fill in the arrow. So we can go 3 and fill in this way forever and ever. And if we do that, what we're really saying is we're going from 3 to infinity, right? 3 to infinity. So we'll write this as saying, well, we're going from 3, including the endpoint, all the way to infinity. And then what we do on infinity is we put a parenthesis, all right? We always use parentheses on infinity. Always use parentheses for plus or minus infinity. And the reason for that is simple. It's basically like, well, you can't ever actually get to infinity. Like you could say, hey, I'm in infinity. And then you'd say, well, I'm at infinity plus 1. You know, it's a whole like little, I don't know, schoolyard fight. Did you have fights like that at school? No? Well, anyway. So you can never actually get to infinity. So you always put a parenthesis next to infinity to kind of indicate that. Okay? And then if you wanted to write that in set notation, your set builder notation, you'd say, so it's x such that, and the way that we look at this is we say, well, anything greater than or equal to 3 works, right? Anything equal to 3 or greater than 3 works. So we'll say x such that x is greater than or equal to 3. Now, you said, well, I thought you said that our little piranha always had to face to the right. Well, that's only when we have 2 in a row. If you've got 2 in a row in the same spot, they always need to face to the right in your final answer. If they're by themselves, they can face whatever way that they want to, and that's fine. The other thing that you want to make sure of is you never want to have your, what's it called? So your inequality signs facing opposite directions. So if you ever have something like this, or if you ever have something like this, that's not a good sign. So don't do that. It means that you probably did something wrong somewhere along the way. So just be cautious of that. Alright. Then finally, you could have something kind of like this, where you say, well, I'm going to start at 3, and I'm going to go all the way off to the left. And by doing this, essentially what you're saying is I'm going from negative infinity all the way to 3, and I'm going to include that endpoint. So again, because it's infinity, we use a parenthesis. It's going all the way out to negative infinity, over 3, ends on 3. So this is x such that x is less than or equal to 3. And you can have all sorts of variations on this. You can go all over the place. You can have, you know, just less than without less than or equal to. They might give you this and say find these two. Or, you know, they might give you this one and say find these two. Or they might give you, you know, this one and say find these two. It just really depends on the problem, but the whole point is just to kind of get you comfortable using this. The last thing that you might see somewhere along the way is something like this. If the entire graph is filled in, going from all the way to the left to all the way to the right, then what you really have is you're going from negative infinity to positive infinity, using my parentheses negative infinity to positive infinity. So in this case, our solution is really, I don't know, you're never going to see that, but that's just for your edification. But really what you're going to say is all real numbers. So if the entire number line is filled in, and clearly it's all real numbers, and the way to write that in standard set notation is to go like that. It's super fun. Interval notation is to do it just like that.